previous class, already we read about the carbocation. Now we are leading to another intermediate, that is free radical. So free radical, now we will discuss about based on the carbon atom. It does not mean that radical is not formed on nitrogen and another atom. Phosphorus atom, nitrogen atom, sulfur atom, everything is possible, but now I am concentrating on only carbon atom. Okay, now, so in previous class I told you carbocation, how carbocation form. So carbocation form, just memorize R2, R3. Okay, now here I given this sign. This sign means full electron going. Full electron means any covalent bond means 2 electron. Now 2 electron leaving the substrate with X. So here X is taking both the electron and becoming minus, and remaining one, that means carbon become positively charged. So this type of cleavage is known as heterolytic cleavage. Okay, so carbocation is formed by the heterolytic cleavage. But when I am talking about free radical, it should be homolytic cleavage. It is forming by homolytic cleavage. What does that mean? It means that the covalent bond, which is made of 2 electrons, will take one electron. So this electron is going to this one, and this electron is going to this one, and giving R1 dot R2 R3 plus X2. Okay? That means here electrons are shared equally by the 2 atoms. Now this is the result of homocatalytic cleavage. Now so we already know about the destruction of the ozone sphere. Ozone sphere means it is in stratosphere and ozone layer protecting us from the sun. So what we are doing so that our ozone layer is destroying? Actually, we the human being are using chlorofluorocarbon too much. This chlorofluorocarbon going to up and destroying ozone layer and converting it to oxygen by the free radical mechanism. Okay. Now chlorofluorocarbon is coming from a cooling apparatus. Cooling apparatus means you are using fridge at home, you are using AC in this hot summer time. So all those things actually releasing chlorofluorocarbon, and this chlorofluorocarbon going to chlorofluorocarbon means CCl2F2 or any combination is possible. Okay, CCl, F3, all those things are known as CFC. This chlorofluorocarbon, after going to up, it converted to it giving Cl radical in presence of obviously H nu, that is light, and this Cl dot reacting with the ozone sphere converting this to oxygen and Cl dot. Okay, so in this way our atmosphere, our ozone layer is destroying, and the harmful ray from the sun and coming to earth and creating lot of cancer, especially skin cancer. Okay, now I am coming to the organic reaction. Suppose you have to prepare alkyl chloride. So one of the path to make alkyl chloride from alkane is the free radical reaction. So take methane, okay, chlorine, and treat with H nu. H nu means sunlight or light. So it will convert CH3Cl plus HCl. This reaction is going via free radical reaction. How this reaction is going on? In this reaction, Cl2 first in presence of H nu converting to Cl dot radical. Okay. Now this Cl dot reacting with this is your methane you have taken. Okay. Now it is giving that type of reaction. This is actually same. When I am drawing this type of arrow means 2 electron involved going or coming, and when I am writing this only, this is called fish hook arrow, only 1 electron involved here. So HCl plus CH3 dot. Now CH3 dot again reacting with Cl chlorine gas and making is CH3Cl plus Cl dot. Okay. So it is a product. This is the one type of propagation reaction. This is the initiation reaction, and the middle reaction is the propagation reaction, and the last reaction which will happen. Suppose you have formed this one, CH3 methyl chloride or methyl chloride. This is the name. But this one also can participate in reaction. How? So CH3Cl. Now this hydrogen can be taken by this one and will convert it to CH2Cl plus HCl. Okay. Now termination reaction. Termination reaction means where two radical forming. So this is your methyl chloride. Okay. So leave it. So my camera is not helping me to go down on the blackboard, so I am writing again the termination reaction of the reaction. So termination reaction is that suppose it is forming two radicals when reacting with each other, it is actually termination reaction. Such kind of reaction will not happen. So when it is happening means here reaction going to finish. Okay. Now I will come in the classification of the radical. Classification of the radical. Just like carbocation, I taught you, it is also can be divided into 3 parts: primary carbocation, secondary carbocation, and tertiary carbocation. So this is your methyl radical. Actually, you know, this is your ethyl radical. Okay, this is your ethyl radical, and this is your CH3 dot radical, and this is your propyl radical. Tertiary. So this is your methyl radical, this is your ethyl radical, this is your isopropyl radical, and this is your tertiary butyl radical. So this is also primary. This is 1 degree, you can see primary, but this is also 1 degree or primary. So for your understanding, you can give a name special primary. Methyl radical or methyl cation, when it is coming, you can say special primary. So ethyl will be 1 degree or primary, isopropyl will be 2 degree or secondary radical, and this is your tertiary radical. Now I am classifying similarly for the carbocation. This radical is on carbon atom, isn't it? So if it is attached to another carbon atom, so we will call it primary. So here is no another carbon atom, so it is the special primary I am saying. But here see the carbon which contain radical, it is already attached to another methyl group. also it is 1 degree of primary radical. Similarly, when the radical containing carbon attached to another 2 carbon atom, it is known as 2 degree of secondary radical, and radical containing carbon if attached to another 3 carbon, it is called tertiary radical. Now, stability. As you know, already we know that 3 degree for the case of carbocation. If you remember carbocation, you can easily understand radical also. It is follows the same rule. Then CH3. So you just memorize. You will see that in carbocation case also, methyl cation was the least stable and the tertiary carbocation is the highly stable. It is also the same thing. Tertiary radical is more stable and then methyl radical is the least stable. Okay. Now where from it is coming the stability? It is the same thing. Actually, radical is a electron deficient species. Just like carbocation, radical also, any radical is a electron deficient species. Okay, so any group giving its own electron to it, it will be more stable, just like carbocation. Okay, suppose if I say tertiary carbocation CH3 and CH3 dot. Okay, remember here also I showed if you compare to each other carbocation and the radical, you will easily understand what I can say. So it is also electron deficient. It is fully electron deficient. It is partially electron deficient because one electron already there. Okay. So this formal charge of radical is 0. This formal charge of radical is +1. Okay. Now here also methyl group has a plus I effect, inductive effect. Okay. Plus I inductive effect means it pushing it bonding electron, sigma bonding electron towards the pillar. Same thing happening. So it will become more stable, just like yesterday elaborately I described or explained this scenario. Okay, based on this one, we did that tertiary carbocation and the tertiary radical both are highly stable among the 4 species. Now we can go for this is the inductive effect, and we can go for similarly hyperconjugation also. Okay, hyperconjugation effect. Again write it. So what I told yesterday, hyperconjugation is a no valence, no bond resonance. Okay, here alpha hydrogen participate in this case. Alpha hydrogen means this is your functional group. Okay, now nearby functional group related to this carbon, and this is your alpha carbon, and the hydrogen attached to alpha carbon is known as alpha hydrogen. Okay, similar thing. So here also hyperconjugation possible. Here also I am creating hyperconjugation. So again, hyperconjugation also saying that your tertiary radical is most stable among the 4 species. Okay. So any radical which have electron withdrawing group. Suppose you have any radical. Suppose you think about this radical. Okay, and this radical. So in between these two, which will be more stable? Obviously, this one will be more stable. Why? Because nitro group has a minus I effect. Minus I effect means it withdrawing electron density towards itself. already your radical is electron deficient, again someone is taking away the electron from it. Okay, this is the, that's why this is least stable and this is more stable, because there is no effect which withdraw the electron density from this radical.